Hey there, stream fans. Welcome back. This is a little bit late to start a stream for me, but it seems like it always works out for somebody's time zone. And we have some light stuff to do, so it'll be nice to have less sunlight around here. And there's still been a lot of cat fussing. Oh man, having 3 cats, 2 of which have been going through surgery, is a lot of work. And it's been a little unnerving for this to be kind of an open-ended foster cat situation where I'm not really sure how much longer I'm going to have to take care of them, but probably still through the rest of the broken leg cloud cat's recovery. So, and then he's been doing great, but it's been stressful because he keeps getting into a lot of trouble. I'm kind of worried that he's going to hurt his leg again, but it seems like he's probably alright. He and Tuco have been getting into the occasional disagreement. And there's Luna. So she's the one who had her spaying surgery on Monday. And she's been annoyed that she's in the box. She's been especially annoyed at the cone. I've been trying to hang out with her a bunch. I was kind of in that blanket fort with her this afternoon, and I made a little window in one side of it so that I think she wants to be able to see out so that she can see like what the other cats are doing, but still feel like she can hide, so it's like she's got a little crack to look through. So yeah, that's the cat situation. Maybe it's steady for a little while. I don't know. We can find out. Alright, and here's the desk. Yeah, this is our robot in progress. It's kind of tall. I've actually got it taped to this circuit board vise, which actually doesn't seem to be a terrible way to work on it, so it's relatively sturdy. Let's actually get this camera going. How is everyone else's day? Wednesday or Thursday or whatever day of the week you view the archives at? Yeah, Cloud and Tuco have both been hanging out upstairs and kind of battling over space a little bit. It's been frustrating. What is going on with this camera? Oh, that's right, I had it completely off to cool. That's better. Usually it's off because the SD card door is open. Cool. Got a couple of lazy evenings here. And the Electronoob asks how the cat queen is. You talking about me or Luna? Yeah, Luna's cranky. I don't know, I've had not the best Wednesday, but it's been alright. I messed up my back sleeping somehow, which is not... I keep thinking, oh, I'm about to say, like, it's not the most fun way to mess up your back, but I actually like sleeping, so it's not the worst way, I guess. But it's been... I think it finally is doing well enough that I can actually stream. Oh, is this not on video mode? I don't know why that other overlay was up. Anyway, I thought on this stream, there's a lot of stuff we could do. This project is sprawling, but I've been wanting to just make progress on assembling the flyer robot, and one thing that's useful for that is to be able to keep testing everything as we assemble it to avoid, having to backtrack to fix problems. So there are a couple of pieces that are a little hard to test right now. Like the sensors, for the most part, we can just read the data out of the JSON dump on the web interface if we really need to. So that the sensors are pretty easy. We can add graphs with just a couple of lines of HTML with the current web front end. The LEDs are a little bit trickier because right now there are a couple of ways to drive the LEDs. So they all involve connecting the LED strips, which are APA 102 addressable LED pixels, to one of the SPI ports on this microcontroller. And so the microcontroller has some code in it that just takes UDP frames, adds a header, adds a footer, dumps them out over SPI with a DMA DMA operation. So the actual, animation and formatting and everything else is actually done in a Rust program. But I've also got this other program from before I had started the Rust daemon that I was just using to quickly test all of this, and that's what you're seeing here. This is just a little Python script, which I later made a version of this in Rust, but the Python version is a little bit easier to just run sometimes. The Rust version was necessary for it to run full speed on a Raspberry Pi, because the Python version didn't use like NumPy or whatever. Anyway, so now what I've got is this kind of colorful test, which doesn't really help me isolate problems that much, but will at least show me that everything is kind of connected continuously. And then I've got this Rust code, which you've been seeing in action driving the LEDs on the winches, if you saw my video on the winchbot or the earlier streams working on that. And it works for that, but I've just kind of had the code for doing the flyer LEDs stubbed out there. So there's like a function that returns a color, and it has some cases where it returns a different color based on what robot and what the function of the LED is. And in this case, I just had some like dummy code that would return a hard-coded value. And so one thing I'd like to do is in this stream go into that code and modify it a little bit, so still not necessarily do the final thing that we want to do, but make it into something that's more useful for just testing the LED strips. And so we could do something with this program, but I think it's better to just go ahead and get it in the final Rust program. And yeah, it's a little harder to tell what's going on right now with this particular test. So I've got these 7 LEDs on each of these 4 sides up here. This is printed in carbon fiber PLA, because, I don't think you necessarily need it, but it helps it be a little stiffer, and I had some handy, and it seemed like a good use case for it. It also gives it an interesting look with the shininess, depending on the direction of the layers on the print. It's also really nice and thin, and just a little bit curved. So this is the very top part of the robot. It goes on top of this other piece that's not within reach, that's the kind of more mechanical core of, kind of load-bearing part of the top of the robot. And you can see it's wired with magnet wire and then some silicone wire here. Playful 1510 says stubbed equals commented, I assume. Well, in this case, stub, I just mean putting in a temporary piece of code that lets me make progress, but isn't really what I want. So I don't even think I needed a comment in this case. It was just, I can show you the code. I was actually going to go into the code in just a sec, so maybe hold that thought until we're actually in the Rust code. But yeah, it was just me putting in some temporary code that would let me test the other stuff that I had written. I almost think of it as like putting in a little dam. It's like if you're trying to build like an artificial river or something, like a waterway or something, and you're trying to get the river from one place to another. Maybe you excavate some part of the river, and you have to put a dam here in order to make some progress on that part. You really don't build things like this. You try to engineer the whole thing and then build the whole thing. But like software is not that kind of an engineering discipline, and you usually have to design things iteratively because there's just so much complexity in so many layers that people haven't figured out yet. So yeah, for any kind of iterative design, I find it useful to, almost think of it like you're kind of plotting your course partway and then setting up a stub, so literally like kind of just like a little end of something that doesn't go anywhere, but has the potential to go somewhere, and then later you'll fill it in. Yeah, I guess placeholder code would be another way to describe this, if that might be simpler. Yeah, sorry to be confusing. So these are just 7 LEDs. These, if you're not familiar with these, each of these little packages contains a red, green, and blue LED die plus a controller chip, and then you send it serial data. It takes 1 pixel's worth of serial data, then passes the rest of it on to the next pixel. So you just see it sold on these long reels, and you can just send it data, and it displays the data. They're really nice. There's a few different kinds that are popular. The 2 most common that you see are WS2812 and APA102 nowadays, and some variants of that have like additional color channels or weird packages. And so these are APA 102s, so they take just SPI data, really, clock and data. So it goes in, and it kind of daisy chains, actually from in to out. So daisy chains like in a circle. I forget exactly which one is first. And then it goes out and onto these rings. And the rings are strips of LEDs going around in this 3D printed enclosure. And then the data is again daisy chained. It comes out, goes into the next ring here. And so these rings, there's a seam where the LED strip wraps around and then ends and then jumps to the next one, wraps around. So it's a little hard to tell right now because the pattern is actually periodic. But if I change the pattern, well, actually maybe it would be instructive just to play with the Python code a little bit to illustrate the pattern. What's the right camera here? Alright, so this is the Python program we're running here. It has this concept of a shader function, which in this case you give it a frame number and then it generates this nested function, which like a closure, but so the idea is up here you calculate anything that's per frame, and then in here you calculate anything that's per pixel. So you call this function once per frame, then it gives you a pixel shader, which you call once per pixel. It doesn't make for the fastest Python code, so you can imagine why this had trouble running on a Raspberry Pi if you understand how Python optimization works. But it was just like a prototype, and it works fine on this desktop computer. So in this case, the overall main function here is pretty simple. It's just opening a socket. In this case, we're sending UDP packets to the microcontroller. It needs a header, which is this message LEDs. Is that right? Yeah, this is just a 1-byte header for the packet that says this is LED data. And then this struct.pack is just converting the integers into bytes here. And we're sending it to the right IP address and port. So that's just, and then the rest of this is like frame rate limiting, or not even limiting, but like sleeping here and then calculating the frame rate. And then the actual pattern is generated here where there's this idea that we have a few different blips that are moving along this whole system. And each one of these is actually a periodic function, which is kind of a nonlinear wrapper around a sine wave. So in this case, each of these are tuples that change per frame and encode the per frame animation state of those light blips that are moving around. So we just have 3 of these that are racing around. In this case, this is the offset of that blip, so just how much it's moving or how much it's moved. So in this case, it's just the frame number times the distance it moves per frame in floating point. And then there's a color, so they can all have a slightly different tint. And then they're all generated using this, like I was saying earlier, there's a sine wave here. So they all have the same width based on so they all, yeah, what is this? This is, I guess this is a little confusing because I didn't use pi here, but this factor 1/10 is the ratio between pixel number and radians through the sine wave. So there's like a frequency in here. You could figure out like how many cycles per meter or whatever if the LED strip had a particular spacing. And that's kind of how I want to be programming animations in the Rust code. So the way the Rust code does this is completely different. It has a map of where the LEDs are spatially. It's calibrated in meters as best as possible, and then you can actually just specify patterns as kind of textures that are moving through space at a particular rate in SI units, which is nice. But in this case, it was just a quick demo. But let's see if we can just adapt this to make something that's a little bit quicker or a little bit more effective for testing the LEDs. So let's just have 1 blip for now. Let's have it move a good bit slower. Let's have it be a bit narrower, maybe. The way you make it narrower here is you basically use a bigger exponent and to fuss with the period here if you want to make it less frequent. So if we want to make them a little less frequent, we could do like that, 20, and then maybe make it a little sharper of a peak. This would be a little easier to communicate with a graph of the functions. And I probably actually do want multiple colors here, but just for starters, let's just put in red. Let's just make a red blip that moves around. Because right now I'm not as interested in making it pretty, unfortunately, as I am in testing the LEDs. Is that working? Oh, I think I might have had the color primaries in a weird order there, because that looked like it might have been blue, and it is moving slowly. We should just go to the Rust code. There's so much that's temporary about this that it's like barely worth maintaining. It's like already falling apart. I guess that's green. That looks right. Let's turn off these overheads, maybe, to get a better view of that. Yeah, so you can see just how many more LEDs are on here. There are many more of those little pulses going around, but it looks like things are daisy chaining right. And so there's one color primary in an arbitrary order. Let's go back to what was apparently red. Or no, this was blue, so I guess it was BGR order in here. That kind of makes sense. Yeah, I've got the seams both on this side right here. Whoa, what just happened? I think we just lost data over here. I think that's exact, or no, we lost clock. Those wires were just twisted together temporarily because the actual distance between these is greater and there's going to be a connector in between. Okay, let's try red. Anyway, yeah, let's take a quick look at the Rust code at least, just since I mentioned it, and then maybe the next thing to do is to, yeah, because like this is probably good enough to test it. It's not pretty, but we can at least get all the LED rings wired and then do some more fun stuff in the Rust code. But yeah, I think that's at least a thing. Let's turn all the primaries on, make it white. Or I think it actually looks more purple on this camera. Even in real life, actually. Oh, that's kind of white. Wow. That's pretty bright. Whew. Let's yeah. That only seems to be using about a ½ amp. It's jumping around a bit, but like between a half and 0.8 amps. But let's try cutting this down brightness-wise by a factor of 10. Let's see what that looks like. Oh, now it looks more purplish now that it's not blowing out the camera. Yeah, running them all at once at full brightness seems terrifyingly bright. I mean, it looks brighter with the studio lights off, because usually when you're seeing this show, I have these really bright lights on here that make everything else look dim. But, like, at night in the shop, these will definitely cast shadows on the ceiling if I run them at full brightness. That's kind of nice, actually. They look very subtle in person. I really like the API 102 current control. That is making this much nicer. Well, Pontificate says, I mean, you want to design your wiring in power supply to be able to handle it. Well, yes and no. I mean, you want the failure modes to be safe and predictable. So I would argue that it's reasonable to build an LED system where running everything at full brightness requires more power than you can deliver, because the ratio between the amount of power you actually need for the animation you're running and the maximum theoretical power can just be really extreme for some of these systems. And so you do want to overbuild it. You don't want to run your power supplies right at their limit, but you don't necessarily need like 100% brightness capability. Even just like thermally, a lot of installations can't really handle that. So if you build your power supply to handle that, then you're just going to end up putting more heat into your LEDs than they can handle. So I would argue that you want your wiring to be able to handle whatever your power supply can handle, for sure, just for safety, because otherwise your wiring melts or overheats. But having a power supply with a working current limit that is actually lower than your maximum theoretical at 100% brightness, like that actually can be beneficial, because it can protect your LED strips from thermal overload. So that's my strategy about this. Let's turn these lights on and do some work, because while these look great, we have one that needs to be healed a little bit. It's not doing too well. I did promise you a look at the Rust code though, so let's go there really quick. Oh, good morning. Nice to travel to a different time zone, virtually speaking. Aw, got some kind words from Jeremiah in YouTube chat, thank you. Wow, this feels almost too bright now. Maybe it is. Anyway, I can turn this off. I hear cats scratching around at something. Somebody's in the litter box, I think. Okay, so here was the, again, the very, very basic Python code. I took an initial attempt at just porting this straightforwardly to Rust, and this was when I didn't really know much about Rust. I was just, reading documentation and trying to figure out what to do and stumbling around. And it was fun, but I didn't really use a lot of Rust features. It looks a lot like the Python code. So this was just a similar effect. I mean, the exact same effect, but I made a version of this in Rust just for speed. But then, when it came to actually making something to integrate into the library for, into the daemon that runs this robot, I wanted something, well, I guess there were a few features that I really wanted here. I wanted to keep it very, from like a multi-threading perspective, I wanted it to be very decoupled from the rest of the bot's control loop. So I didn't want like a possibility of the animation requiring a lot of CPU or crashing or just failing in any way. I didn't want that to be another reason for the main control loop to fail. So having some fault isolation was good. Having them take advantage of different cores was nice. So I wanted it to kind of run on a separate thread. And then thinking about Rust's, the way it likes to do multi-threading is to, you can share data between threads and take locks and that kind of thing. But a lot of the power, I think, in Rust is in how easy it makes multi-threaded programming that doesn't rely on locks and doesn't have data races, and just it provides some really nice primitives for, I guess I especially like its message queue primitives, so I use that a lot. So then it starts to look more like you have this separate box of software where you send it messages about the current state of the LEDs, or like what you'd like the animation to be doing. And these messages come from the bot control loop at whatever rate it's running at. And then the animation thread is running at some different rate. In this case, it's running slower because the frame rate doesn't need to be as high as the control loop rate. And then in there, I can actually use multiple threads if I want to do the LED rendering. Right now, it just does it all on a single thread, but if we had any LED performance problems, that would actually be very easily parallelizable. And then it uses a similar shader sort of approach where you take that information about the entire LED LED scene, and then divide it up to this, pure function that just takes the information about that LED and the overall environment for that frame and generates a color. Yeah, I won't pontificate is pointing out that a lot of switching power supplies like to be run a little under the maximum. Yeah, definitely check out your power supplies datasheet if you have concerns about efficiency. Because there's often a curve there that tells you something useful about at least what they measured. Alright, so LED. Yeah, so the external interface to this whole LED thing, who uses this light animator? I think the controller owns that. Yeah, so this controller is really the heart of the daemon here that runs the Tuco Flyer robot. There's a lot of stuff that I could split off into separate pieces, like there's a separate piece that handles the UDP communication with the robots, and there's a separate piece clearly that handles the LEDs, because that's what we're talking about. A separate piece for controller input, but all the stuff that kind of just has to be like just a control loop reacting to inputs and then generating a response, that all runs here. Oh, Tuco's over here. Hey, buddy. I hope Cloud's okay. You didn't hurt him, right? There was just some hissing at Luna. Ah, the hissing is not great. It would be great if the cats could get along better. So this light animator actually just starts a totally separate thread, which we communicate through a pretty narrow channel, which is represented by this object we get back, which is actually, what is that? That then gets passed on to controller state. Hey, Took. It's this light animator. And yeah, then every time we have one of these lighting ticks, which is basically just a rate-limited callback that happens at about 250 hertz, but in response to a particular packet coming from one of the robot microcontrollers. This ends up calculating a new light environment, which is how it represents all the controller state that needs to be sent over to the lighting thread. So in this case, this light environment method is actually what looks at what the controller's doing, evaluates that state, and then figures out, in light of all of this stuff that's going on, what do I need to tell the lighting thread about this so that it can do the animation? So there's kind of an opportunity to divide responsibilities between what's the lighting animator's responsibility and what's the control loop's responsibility. And some of that can get a little abstract and could go either way. One more practical thing that lets you, or that let me kind of decide what goes where, is also, I decided to just interpolate all the data that gets sent to the lighting animator. So anytime you generate one of these light environments and send it over to the lighting thread, on the receiving end, when the lighting thread is actually going through the environment that it receives, it'll actually do some tweening. It'll do animation interpolation so that it smoothly fades to the desired state, which means that even if the control loop just instantaneously switches modes, from normal operation to halted, or into or out of force limiting, then you won't have just an instantaneous on or off, which I just don't like the look of those with LED animation, and this was an easy way of just adding in a little bit of smoothing to everything that goes into the LED animations. So yeah, and then this light.update is just sending this light environment to the other thread. So here we have some embarrassing trailing white space. So yeah, we actually end up going and asking the winches for their own light environments because we have some of that separated out per winch. And then And then there's a bunch of stuff that's not per winch. And all of this, boringly enough, is just copied from the configuration, which is loaded and saved persistently. You can edit it from the web interface. So that's like when you're dragging around sliders and changing colors in the TucoFlyer web interface, it just updates these values and they're pulled in on the next tick. Walt Pontificate asks, are you using a library to drive the LEDs? That's what you're looking at. That's what I wrote, basically. It consists of this Rust code that's designed to it gives you a separate thread that does the LED animation. You can kind of lob new states at that thread, and then the thread tweens between the old states and the new states. And it also handles running it at a consistent rate. It handles calling a shader function on each LED. It handles building models of your whole system of LEDs, along with coordinates for all the LEDs. It's a lot like some of the stuff I've done in Fade Candy before with C++, but just a little different in Rust, a little bit more to my needs for this project. And then this sends UDP packets to some microcontrollers, and there's not really a lot going on there. There's no library or anything. It's just a little bit of C code that does a DMA transfer from a network packet. That's pretty much all it is. Yeah, the API 102s are really simple enough that they don't need much of a library. I mean, I can show you really exactly what the library consists of on a couple of pages of code here. I should also open the firmware, because I guess that's relevant. Yeah, so here's the firmware that's running on each bot. So there's this. It's less than 100 lines of code. So we have LED initialization, and this is just setting up a bunch of hardware and setting up a buffer in memory. This could be more efficient, but in order to simplify the DMA operations going on here, what this does is anytime there's a network packet coming in, I just memcopy the relevant part of that into this LED buffer that's already in exactly the right format we need to send out over DMA. So another way to do this would just be to already require the right header and footer on that, but this kind of splits up the responsibilities so that the header and the footer before the LED data come from the firmware, and then the actual LED data, which is formatted just like the APA 102 wants it, that comes from the Rust code. So we don't have to transform every pixel here, but we do have to actually have a header and footer. And there are a couple of reasons for that. I think the most obvious one here is so that we can clear all the LEDs. Because this lets LED init here just set up a packet that has all the LEDs turned off. Because otherwise you actually power this thing on and the LEDs just come up in a random state. So this sets up the framing. It expects 0 bits at the front and 1 bit at the back. And then each pixel has 3 1-bits at the top to kind of act as per pixel framing. If you don't have these, then the LEDs just will stop driving the frame and they won't actually you won't actually do an update. So in order to successfully clear all the LEDs, you need to at least send them the right framing bits. And then I'm just setting up a bunch of hardware through the peripheral library for this chip. This is the copy that I just described. And then, yeah, all it does is it does a DMA write. This is just taking that entire structure that we just saw up there, which is already laid out in memory in the right format, and it just takes the address and the length of that, gives it to some hardware, and the hardware DMA engine just starts concurrently with the processor accessing that same memory and reading out the data to send it out over SPI. You'll see that it looks kind of bursty on the SPI bus still, because sometimes like there's a hardware buffer in the SPI peripheral. That buffer then sometimes has to wait on data from RAM, and so there's a little bit of jitter there, but it means the processor doesn't have to babysit the transfer. It can just send it off. Yeah, and the WS2812s are easier to wire. They have 1 wire instead of 2 in and out. But yeah, they're more picky with timing. The modulation rate is slower. They're harder to drive from like lower speed microcontrollers. And they don't have the dynamic range of the APA 102 with that extra 5-bit current level control that you have in the top byte. So the APA 102, they have this 32-bit frame for each pixel. There's 3 start bits, then there's 5 current control bits. So you can actually control not just the pulse width modulation for the pixel, but you have this 32 level granularity control for just how much power you feed into the whole system. So that actually gives you a lot more freedom to have very dim pixels that aren't super flickery. So I tried doing something that compromised with the WS2812s in Fade Candy, where on top of the pulse width modulation, it did a slower level of temporal dithering that allowed you to get, you know, a simulation of darker colors and more nuanced steps between the colors. But the current control in the APA 102 is a lot nicer when you can bother with the extra wiring. So yeah, this is the entirety of the firmware control for the LEDs at least. And then in the Rust code, I need to go. So yeah, we do have this. This is the only APA 102 specific code we really have in Rust. So this is a function that goes from a floating point color, which in this case, a vector 3 is just a fancy name for a fixed length array with 3 floats. And then this vector math library has a bunch of functions that can do vector math-like things like multiply and add and dot product. But it's really just a fixed length array. So we take that in. The output is really just an error code in this case. We don't really care about the length. I'm just using the same signature as the write here because it returns the number of bytes written. But mostly we're just returning a success or fail here. And so this just, and there's not really much of a reason for this to fail. It's just that because of the interface here, this is a writer, so the thing that this does is it takes a color and then it writes it to something, and the thing that it writes to is an object, well, a struct in this case, something in the language which implements this write trait. So Rust isn't really object-oriented in the same way that you might be familiar with, like C++ object orientation. So, or like Java, for example. Like in Java, write would be an interface. In C++, it might be a mix-in class or something like that. But in this case, it's a trait, which is just kind of this standalone thing, which is a lot like an interface, but in some ways way more powerful. It takes a little while to wrap your head around them, and I don't know that I understand them well enough to really explain them right now, but the Rust book does a decent job of getting your feet wet with them at least. And it has a lot of nice metaprogramming features. Like one of these traits, like write, for example, like it itself can be a type that takes type arguments. So just like you might have templates in C++ that work with an abstract type, and then you can kind of customize them with specific types. You can do that in Rust. It's really nice. But in this case, we're just using this to write a sequence of bytes. So the idea is you call this function repeatedly on each pixel, and then collect the results into a buffer, and now you have exactly what needs to go over the network. And this is where I started trying to map a more linear idea of color into this separate like pulse width modulation plus 5-bit current control world that the APA 102s have. And right now I'm just assuming that they're both pretty linear, and so I'm just treating it as 5 extra bits effectively. But if you look closely, you can see that it isn't quite, like if you do a slow fade, it's not going to be quite monotonic. There'll be a little bit of jumping up and down with this scheme. So I might want to look closer at the light output and try to calibrate these things into a monotonic brightness curve. But yeah, that would also require modeling the time response of the human eye. So it would be a complicated project. Anyway, this also has some type conversions. Rust is very specific about types. So if you're going from double to single precision float, then you have to specify that. If you're going to integer, you definitely have to specify that. So that's what we're doing here. Oh, there's a lot going on in the light animator. We're doing the interpolation here to smooth out the inputs. This animator thread is the thing that just runs separately, and you send it light environments, which describe what you want the animation to do, and then it just hangs out and renders frames. So some of this is about receiving those light environments and interpolating them, and some of this is about limiting the rate those frames happen at and keeping that consistent. This is what I just mentioned with writing together the pixels. So this is actually rendering the frame, and we call the shader function to generate a pixel. The environment is constant for all the pixels. This is the thing that we get from the other thread and then smooth out from frame to frame. And then the pixel mapping here is the individual data that's associated with all the LEDs in the robot. So this is all generated ahead of time by this models file, which it's a little monotonous because it's like doing hard-coded vector math to lay out the dots in the different parts of the robot. I actually made a better visualization of this. I think I still have that handy on the Windows machine. I wrote some code to export all the LED points as a .xyz file, which is just a list of numbers, pretty much, and then we can view them in Rhino. It would help if I could type. Oh, do I not have those files here? Okay, maybe we have to regenerate them. I don't know if that's super worth going into right now. It'd be more fun just to show you an animation on them. Yeah, that's what this thing was. Actually, that's easy to do. We can do that. Save LED model. Unless I already have the files here. Is this PowerShell? Oh, Dark Samus says Rust in the title, and then they were getting annoyed that there wasn't Rust. But yeah, now there's Rust. Sorry, it took a little while to get to the Rust. Yeah, while that's compiling, what is this actually doing? 2-point cloud file. So this relies on a bunch of sorry, I keep tripping over my own words. I'm desperate to get them out sometimes. So 2-point cloud file here is one of the utilities in LED shape. So this is where I have some primitives for lines and circles, saving in that super complicated XYZ file format. I had to add a few utilities to the vector math library, like this arbitrary perpendicular vector, but it's actually got a nice approach where you can rename the vecmath library to vecmathlib, use all of that. So use is Rust's way of importing stuff from another library, but pubuse lets you import it and then also re-export it. So this is effectively making a derivation of this original library that adds some additional functions. This is actually what the library authors recommend, since so much of the time you have a vector math library that does most of what you want but isn't extensible at all. So this was their answer to that problem. Kellet says, was learning Rust something you would say was easy, average, or hard? I know it was new to you. Learning the basics of Rust I found really easy. There was, it took me a little while to get my head around some of the more advanced uses of traits. So I was trying to read some code, using a lot of futures and like interior of Tokayo, which is one of the async IO frameworks. And so there's a lot of complicated stuff in Rust that I'm still getting my head around, and that it's taken me a while to get this far. But I found the basics pretty easy to get started with. Like this LED tester that I ported to Rust, I just wrote this by fumbling around with the Rust book while I was, I was just like reading documentation and trying to figure out what code to write. And I think that part of the language journey is relatively easy now, because especially if you look at like the Rust book, especially the new version that they've been working on, I like it. It seems like a good way to learn Rust. There's also just a lot of code you can read, and I find I like learning from reading other people's code. It takes a while to figure out what is worth spending the time with on crates.io, but that was just a process of looking at dependencies and trying to figure out like which of these libraries are being updated and which libraries seem to be documented well, and just kind of going through that. Anyway. Well, there's a lot we could go into here, but I think the core of this that I really care to explore is the shader here. And this is what also describes all the data types that are relevant for this. So this is kind of the intentional, like, well, if you're working on the animation, this is the file you want to be in. So it has the data types for everything going into and out of the shader, and it has the function itself that generates the colors for all the LED pixels. Let's see if that compile is done, so we can at least, yeah, great, saved LED models. So then we have the .xyz file, and I think I just have to grab that network share from this machine. Can I do that? As I discover my own network infrastructure live on television. I think we want to... Those aren't useful. This is useful. That's better. This was just in GitHub, right? Why is it in documents too? That's really silly. There we go. Winch LEDs and flyer LEDs. So winch LEDs is pretty simple. We've already been using this a lot. Oh, why did I expect that to work? Can I just drag this into Rhino? Oh, it's asking me what to do down here. Open file, yes. There we go. It's a very simple 3D model here. So each LED is just a point. Here's an LED. Are they numbered? I don't know if we can figure out which point is which here. But I don't really care right now. It's just useful to see if they're in the right place. So this is supposed to be pretty physically accurate. Like, I actually measured where the LEDs were in the model and tried to keep them in here accurately. So there's one strip on each side. It's 7 LEDs per strip. It's the spacing between the LEDs is based on one of the standard spacings that this LED strip tends to come in, which I think in this case was 30 per meter, or maybe it was 60 per meter. The code should say. But anyway, let's look at the other one. The other one's a bit more complicated. Right, drag and drop. Flyer LEDs. Yeah, so that's the model for what the flyer should look like. So here's the kind of plus sign shaped array we have at top, 7 on each side. And then here's the set of 3 rings. I don't know if it's easier to see when I zoom in because the points just stay small. So that's all generated by some code in Rust. I could have had that read in from a file, like I could have actually just built that in Rhino and exported it as a point cloud, which is maybe how I would have done this in other projects, but here it just seemed easier to define in code. Where's my mouse? Right. So that's what comes here. Yeah, so the winch just had these two lines. Yeah, 60 per meter. And then the flyer had 4 lines that were all rotated. And so here you can see I'm doing some more vector math. It is useful to understand at least some linear algebra to do stuff that involves spatial coordinates. So if you look at these templates here, these are just functions where you can say, I want to make a line out of LEDs, or I want to make a circle out of LEDs. And then you can give it some stuff that is in common between all of those LEDs. So this pixel usage, and then information about the shape of the LED strip. This is just like a convenient way to collect arguments for these templates. But then you give it, this is the output vector, so it's going to just push pixels into the end of this growable array. But to specify where the line is, you give it for some of these floating point vectors, you give it a center position, and then I'm specifying the angle using a tangent. So in this case, it's just any vector. It doesn't have to be a unit vector because I normalize it down here, but just any vector that's pointing in the same direction as the line. So it kind of starts from the center and then goes in the direction of the tangent and in its kind of opposite direction. So some of you, this might be obvious to some people, just like how you would do that, but I often think about this in terms of coming up with, well, in this case, I have a discrete number of steps, which map to the different LEDs in my flyer. I know how many LEDs there are. So I can loop over all the LEDs here, and then I can map those to a number that has some convenient range to it. So it's common to want to get it to a range of 0 to 1. So I'm converting that integer to a floating point, then where's the minus 0.5 for here? I think I wanted... Oh, that's right. This is not 0 to 1. This is minus 0.5 to plus 0.5. So the domain that was useful here was to think of that unit distance as the length of the whole LED strip. So if you were to go from 0 to 1, that would be the whole LED strip. But you could also go from minus 0.5 to plus 0.5, and that would be the whole LED strip. And since I'm centering it on a particular location and kind of twisting it around that, it was convenient to think about this iterating from minus 0.5 to plus 0.5 around that center location, and then just rotating the whole thing. And in fact, you don't even need to do the rotation because this can just scale that tangent vector. So you can think of the center as a point, and then the tangent vector as starting out as any arbitrary length. Then you scale it so it's a unit vector. So it's always, the length is 1 no matter where it's pointing. And then by scaling that again, you can make it whatever length you want. So in this case, we can just use the length of that to reach from minus 0.5 up to plus 0.5, covering that whole line. So lines, lines involve linear combinations of these parts. So we just take the tangent vector and multiply it by something and then add it to the center vector. But the circle, there are a few different ways you can think about the circle, but here the way I'm doing that is by making a radius vector. So similar to that line vector where maybe it started at 0 and then it would kind of extend out to 0.5. Now I'm thinking about a radius vector which points from 0 to the edge of the circle, and then I'm just spinning that around as I iterate over the LEDs. And there are a bunch of ways to do linear arithmetic, matrix multiplication, and various kinds of linear algebra in Rust, but this particular library is super bare bones, so it doesn't try to have fancy data types. It uses very simple data types, intending to just try to be compatible with other libraries. And so you end up with functions like this that are kind of heavily namespaced, like row major matrices, transform position, etc. Anyway, let's go back to the shader. So this is the light environment that I mentioned earlier. This is that collection of just everything that flows from the controller thread to the lighting thread, and then this whole thing is interpolated automatically. I'm kind of happy with the way the interpolation works. It uses the serialization, so these are macros that will automatically traverse through this structure at compile time and generate functions that know how to use a serializer or deserializer trait, like one of these interface-like things, to kind of funnel all the data in this structure into or out of some other object that implements those generic serialization traits. So you can use this to arbitrarily serialize data. One really convenient thing you can do with it is slurp data directly from these structures into JSON. And then conversely, you can take JSON and with like strong validation for all the types in here, you can deserialize it back into the Rust structures. So I use that for a lot of stuff here. In JSON, also serializing to binary for UDP packets, which is like just using the memory image of the structure, except you can kind of decouple those two things, and you can use the serializer to always have things tightly packed in whatever order you declare them in. But then in memory, they can be more loosely packed. The compiler can reorder things. So a lot of this stuff doesn't really need to be interpolated all the time because it's not gonna, like, it's coming from the configuration. But it does help to interpolate if I'm like dragging the sliders in the configuration, or if you change configurations. And in fact, changing configurations is actually how some of this stuff works. Not that you change the flash exponent that often, but like the winch command color, for example, like that's generated by the command thread based on the state of the winch, a bunch of other things. If any of those things change, then the resulting color gets smoothly interpolated over a few frames, whatever that's set to. So winch lighting is just the per winch part of all this. Pixel mapping is the data that that model we were just looking at generates. So a lot of it is the location. This is what we were looking at in the CAD model, that just XYZ point. But in addition to the XYZ point, we also have this enumeration that says, well, what are the semantics associated with that pixel? What are we really doing with them? And that's how we can disambiguate between the winch and the different parts of the flyer. So the winches, they have a number that says which winch they are. We usually don't care, but that's useful sometimes. And then the flyer has these two parts so far. And then within the ring and within the top, it might help to add more data, but for the most part, I'm planning on just using the location data to animate these. So I've got just a few utilities here that are used in the animation, but the business end of it is this function here, which is actually the implementation of the shader. And it uses Rust's matching primitive to take this pixel mapping, which can be an enumeration, one of several different kinds of types, and it sort of destructures it apart into one of these different matches. And this doesn't have a default case, so the compiler will actually ensure that we're covering all the cases. So the winch animates by kind of mixing together a few different animation sources. There's the base color, there's some flashing combined with a flashing function, and there's a few more of these wave functions. But this is the placeholder code from earlier. This is where we're just returning a plain old color. So anyway, I want to get into adding some more code here a little bit later, but I think this might be a good time to switch back to the physical world for a little while and try to fix this LED strip, since that's going to require letting some glue dry before we can really test it anyway, so good time to dig in there. And I think it's just as simple as a bad solder joint. So there might be a simple way to get in there, but I think we're going to have to take it further apart to get to the solder joint that needs fixing. Alright, let's gently put that aside. Alright, so these are more of the same LED rings that you saw over here. Oh well, this is the third. I printed 3 of them. I guess that would make sense. So it's 2 of these identical black PLA parts, and then this middle translucent part is printed in NinjaFlex. So... and then I had this held together with hot glue that's been dyed really opaque black. It's actually really nice for sealing stuff that you want to be kind of light tight, but you can still take it off with isopropyl alcohol, so that's what I did here. I just kind of soaked the area in isopropanol and wedged it apart, and the hot glue just gets crumbly and comes apart then. So I just wanted to get the big globs of hot glue out of here. There mostly isn't that much. This design is also a little weird. These 2 pieces are rotationally 180 degrees symmetric. So like they're identical. One piece has a notch on this side, then you print, 2 of the same pieces. The other piece has the notch on that side. They fit together. Oh yeah, send is sad. I think that send is sad error would happen if you unplugged the network cable and it no longer had a network with that IP address reachable on it. And that method of handling errors in Rust where you just say expect or unwrap, those will just end up killing the thread you're on if that error comes through, because it's just assumed that that error is something you've decided not to handle. And, that's not the worst thing in a lot of cases, especially if you've designed your system to have separation of concerns between threads. I'm not going to really bother digging the hot glue out of there because I don't think it needs to come out. That's just, like, because it's symmetric, there are 2 places you could have put the wires, but the wires are all on this side. Alright. Oh yes, we all missed you, Anonexus. So this is fun. It's translucent, it's flexy. I printed it with concentric infill, so it's not very strong, but the light is pretty uniform as you rotate it. It's also completely out of focus. You can kind of see the infill there, just these concentric circles. It's kind of robot-y. That aside too. Alright, and here you have a mess of mangled LED strip and hot glue. So how far do I have to take this apart? I think I decided this screen wire is the one that's busted. It's under that joint right there. Maybe we can get at that without a lot of fussing. Although this shouldn't really be glued in. This should just come out at this point. There might be a little bit of glue, but it's not really glued in. Oh, is it the glue around here? Maybe some more isopropanol. Yeah, this piece of glue is still kind of in the way. What kind of digging tools do I have? Flat-bladed screwdriver is a classic. That needs more targeted isopropanol. Oh no! Nexus melted the corner of a display. That's sad. I'm sorry. Those things always seemed so mysterious to me as a kid. Like, I don't know. I guess like the whole process of like epoxy encapsulated components kind of held this mystique. I had some excuses to make my own epoxy encapsulated components once, where I made the most delicate dead bug style surface mount to dip adapter, and I just decided that to make it more usable, I would just pot the whole thing. Which, you know that if you're potting your electronics to make them easier to use in prototyping, something has gone terribly wrong. I've exposed some more glue that needs isopropanol. Yeah, like, I should probably just take all of this glue out and then inspect the solder joints, because this one blob of glue is holding it in, but once I get that out, it'll just come out really easily. I do like using hot glue for semi-permanent installations like this, where I want it to be sturdy, but I also want to be able to get in there. And you can kind of get into E6000 by peeling it off, but it's really unpleasant. Oh my gosh. I should have picked up more beer before this stream. I think there's still some beer, but there's not much. And it would have been nice to have an IPA. We mostly have light beer right now. Will that come out yet? I can clean this up outside. I think this booger is still holding on. I'm just running out of lever points because I don't want to like squish down right there. Internexus says they spent a year potting everything simply because it was fun, and then you can't replace the bits you eventually burn out because you didn't mark pins. Yeah. I found something really fun about the, like, kind of the fantasy of having like a shrink-wrapped product or something like that. Just the idea of having something that was encapsulated and you could kind of have this boundary between this like little perfect nugget of something you put together and the chaotic outside world. I remember going through some stuff from, like, I don't know how old I was, I was probably like 8 years old or something in that vicinity. I found some stuff from that era. And I found these hand-labeled floppy disks. Oh, actually, I have some of that here. That's why it came up recently. Because my dad sent me a couple of boxes of just really old discs and CD-ROMs and stuff from their place. And I was going through there and I found some stuff that I made. And there's like a hand-labeled disc where I remembered like making little boxes and like box art and sleeves and stuff for my games. And not that I really did that, like release that much. Like these are like a couple of little text things where you could move a character around and pick up some items and do a few things. But it turned out, even at that young age, it was easier to get distracted by writing game engines than by writing actual gameplay. Yeah, I made my own installer for it even. I forget whether it was a batch file or if it was written in BASIC. But I think some of this stuff was in C, but the early stuff was in BASIC. And I definitely used some DOS batch files to get it all running. Another layer. Excavate. We've just got that little nubbin of glue in the middle. I mean, I don't need to be that gentle on it because I am removing it and I'm about to do like a serious refit on the solder joints anyway, but there we go. Now it's out. Let's put the LED strip aside. I just want to clean up this bottom piece before we put it aside because it's already wet with isopropanol and that'll make the glue soft and needs to get out. So with all this glue down here, imagine there wasn't a lot of actual room for the wires. But like I squirted this in around the wiring. So the wires must have just not been in a great place this whole time. Alright, that's clean enough to reassemble. I don't need to get this completely clean, because as soon as we fix the LED strips, I'm just shooting it full of the exact same glue again. Alright. So we can see a couple of puny little solder joints that I might want to reflow, but they're probably fine. The actual problem joint, I think, was this top one on the left side, which I could imagine that's a problem joint, but let's try to get this glue out from underneath the whole mass first. Oh, there's also, I don't know, it just looks like the whole thing was crunched a little bit trying to put it in. This top edge, it's like keeps being out of focus on the camera. There we go. The top edge is folded a little bit, like it wasn't quite in the right place when I put it together. Should we give Servo AF a try? think that needs some isopropanol, and I'm gonna get one of the few remaining beers while I can. No, there's only one beer left. I'm not gonna take the last one. I think Zach might want one later, so I should just walk to the convenience store if I actually want a beer. Can I stream walking to the convenience store? I could. I don't know if I could do it without interrupting this broadcast. Ah, that is satisfying. Just kind of squidging those out of the way there. Oh, cool. Glad some of us are feeling Servo AF tonight. Len says Twitch has an IRL category now. Yeah, I got kicked off of that already. Oh, you're saying for the convenience store thing. Oh, yeah, maybe that would be more in kind, but I still just don't understand Twitch communities. I have my channel set up without a Twitch community right now. My scanlime channel didn't get kicked off, but my Tuco Flyer channel did. And I don't know if scanlime would be right either, because like after I looked at the rules for IRL more closely after Tuco Flyer got banned, it was like, wow, these are actually super strict and I don't want to deal with them right now. Oh, Thomas says, did you ever figure out the money situation? Oh, that's a complicated question, but do you mean just with Twitch? Yeah, if you're referring to the Twitch monetization stuff, so the story with Twitch is when you reach a certain size, they send you a message being like, you can enable monetization features now. So I got that message, and then I was starting to go through the process, but I was reading the fine print, and they require that your Twitch stream is a unique audio-visual performance or something, and they have exclusive rights to it for 24 hours after the broadcast. So they basically want people to completely 100% buy into the model where you stream on Twitch, then post archives elsewhere. But so to get like any monetization on Twitch, you have to only stream on Twitch is the strict reading of that, as far as I can tell. I'm curious if I should bother trying to do loopholes around that, because I can just imagine having you know, putting a couple extra command line arguments on my transcoder here and just having it add an overlay, very subtle, on the Twitch stream that says this is a unique audiovisual performance. But I don't know, like they can just shut my channel down if they want, so like that's just poking a beehive, right? Oh, Cody asks, can you stream just one camera angle on Twitch then? Yeah, I mean, that was kind of what I was doing with Tuco Flyer, which I think the main problem with that is when it was just streaming and I didn't have a person on. But yeah, I don't know. I'd have to go look at the fine print, and I'm not really sure if it's worth fussing with right now. Hi, Zach. Well, I think we've got all the goop out of there, and now it's tempting to desolder all of these and bend it back into shape, but I just want to look at it under the microscope and see if we can actually find the problem first. Because right now, I am still working on a hunch, right? And I want some confirmation. But speaking of multiple camera angles, I was looking into, oh, somebody brought this up on Twitter. I'm sorry I'm spacing out on who exactly it was, but they brought to my attention that YouTube lets you stream multiple video angles now, and you can, if you enable this feature, then I guess you end up with a player that has thumbnails for each camera angle at the top, and then you can switch between them. I haven't seen this used anywhere, but maybe it's used a lot on sports streams or whatever, and I haven't been watching YouTube Red or whatever. I mostly watch small channels. And it seems pretty resource intensive. It needs a completely separate H.264 stream. It isn't like you're interleaving them somehow. I don't know how it keeps them synchronized, or if it does. But yeah, it seems interesting. I might be able to do it here. I don't think I could do it with just one instance of OBS, but if I tried running multiple instances of OBS maybe, or I could definitely do something where I stream both the main encoded output from OBS and maybe one of the raw cameras. Like the overhead camera here already spits out H.264, that's why it's so laggy. So like, this is already something I have an H.264 stream for that I could just send directly to YouTube maybe. But I don't know if that would be interesting. That might just be kind of creepy. And I don't know. Tuco Flyer is going to be kind of that anyway, but at least with that, you'll be able to maneuver it around and harass my cat. I mean, I hope people are nice to my cat. My plan is to design it so that it isn't really possible to bother anyone with it. That's the plan, at least. Oh, interesting. Morgan says they're using H.265 FrameSync. Oh, interesting. So, I assume I would have to insert something on my encoder end, and I doubt any of the encoders I'm using actually support that right now. I think the problem is on that top wire. Let's... It could also be on the LED package, actually. Let's try to see where this is supposed to be going. The meter. Nexus says thin clients running OBS, one for each camera. Yeah, OBS, the requirements I would imagine for a machine that I'd want to run OBS on don't really speak thin client to me. Yeah, like it's nice to have a GPU, like a discrete GPU. But yeah, I mean, I have a couple of computers that would be powerful enough, and even just like the one machine that I use right now, I know I can do multiple encodes on it because like that's how I'm going to do Tuco Flyer. But I don't know that I would do more than two. Like 2 is already a lot. So the test I was doing before was actually just resistance to ground. Let me try that first. So ground is up here. I'm going to try not to touch anything. $390K. That one's $257K. Oops. Let's retest that now that my lead slipped. Yeah, still 390. And then there I've got infinite overload. So this solder joint, the wire is still attached, but whatever this pad is usually attached to is not attached. So it could be the via. We should test that. How is this constructed? So there's a via right under there. So this cut line up here is the same as this pad right here, which is the same as that pad. It's a very tight repeating pattern. This is that fairly dense 144 LED per meter strip, so they just really pack in the LEDs. Okay, so second via from the left. Where does that seem to go here? I'm going to put it in beep mode, and let's just see which pin this is supposed to go to. Is it just that corner pin? Did we just crunch the corner pin solder joint? So it looks like there's a via right there. Is the via redundant? Because if this is plated, then it would be plated through right there and also at the via. But maybe they just assume people might just cut off this entire thing? I don't know. So I'm going to grab the green wire in one probe. So I should be able to get continuity to that second pad. Yeah, but what about the via? Can I poke in there a little bit? Probably can't, because this is like epoxy coated. What about this? Ah. I think the problem is coming from inside the LED. That's a shame. So is this a popped bond wire? Is that... Can we actually see a bond wire glitch there? This might just be a matter of replacing an LED again, just like splicing on another LED from that tiny strip of spares. I'm down to like 2. I mean, I'm less worried about the individual... I don't know. They might look... I'm just like maybe being a little bit too attentive to the differences between the individual runs of APA 102 LED I have here. I would just hate to do a fix and then find out that the LED I replaced is now a slightly different color than all the other LEDs. That would be annoying. But I'm going to tape this down and see if we can get any closer and just see the problem. Playful 1510 is asking why we're looking at LEDs. Thought we fixed him yesterday. There's more. There were two that needed fixing. There was the little strip on top, and there was the ring. And so now we're fixing the ring. Bond wire seems fine. It's interesting. I don't know where the fault is. I mean, it could just be something we can't see, but I'm curious if I can reproduce that resistance measurement from the top side. So I think negative probe on the ground, and then if I probe some other input pin, it's about 300K. If I probe this one right on the top, what do I get? Oh, why am I getting 300K now? Okay, what changed? Let's test the green wire. Oh, is it just an intermittent solder joint? Maybe I should just reflow that and test it. Alright, my current best theory for what's going on is that there's just a very subtle defect in one of the solder joints. So I'm just going to reflow everything I can, and we'll see if that fixes it. Let's use the little soldering iron. We don't need to be so close now. Oh, Morgan is asking about the discoloration on the die. Yeah, a lot of these have little defects in the clear molding compound, so that doesn't seem to necessarily be a problem, although that is certainly one thing that can happen when you do overheat them, so like it could indicate a problem, doesn't necessarily. Great. Let's get fluxy. Yeah, don't melt the corners. I'll see what I can do. Yeah, see, it would make sense if it was one of these solder joints, because look at how crushed this got when I was installing it. In fact, maybe I should uncrush it before doing the reflow, so that I don't just end up recreating the exact same problem when I try to uncrush it. Yeah, man, that was such a... I keep underestimating how sensitive these LEDs are. I thought the APA 102s might have been a little bit better, but it was still really hard to move one from one strip to another without just killing nearby LEDs. Yeah, Morgan says it might be a problem with the via also, maybe. What do you mean by delaminated the via? Oh, you're saying that they were probably like two separate copper sheets, and then there was a hole punched, and then it was plated. And so that little interface might have come apart, I guess. Yeah, I don't know how they do vias on flat flux. So the thing that's confusing me, though, is that the via that would explain the intermittent behavior we're seeing is not on the edge of the circuit board. It's in an area of the board that didn't seem to be damaged. But if you saw a via that is damaged, then I would be interested to know more. Come on, heat through. And it's tempted to let it get only kind of hot enough, but it actually really needs to get thoroughly melted to form a good solder joint. Just do that. Hopefully not overheat this whole assembly. There's already a lot of heat in the board, and so these data pins also, there's not nearly as much copper connected there, so they heat up faster. There's also all of that copper is connecting the two layers. I would be surprised if it was a via problem, but certainly haven't ruled it out. This one's going to take more heat. Alright, let's reflow the chip on the other side. And then test this, see if we get any signs of life. If we need to, we can replace the first LED. We just need to make sure the splices in that case are strong. I'm not gonna hot air off an LED again. I'm just gonna splice the strips. But then the splices need to be mechanically pretty nice. Oh, I should flux that. That was a loud one. You may be saying, we killed an LED by soldering it before, but I think the problem was the hot air, not the hand soldering. I think there's too much heat gets into the potting compound when you hot air. Oh geez, come on, thermal. Okay. All right, let's see if that's alive. Current theory in chat is they used trained mites with minuscule welding apparatus. Yeah, that sounds right. Oh, D. Bryson in Twitch chat was saying that maybe I could create some kind of gadget or software that's useful for Twitch streamers, so that they might promote me as using the gadget or software. Yeah, maybe. I mean, I could certainly take another shot at the channel switcher thing, but I guess I don't know how much people need that. So much streaming is just sharing exactly what's on your screen, and it doesn't involve as much physical world type stuff. But then I think the Adafruit folks did a channel switcher project recently because they're more interested in that. I don't know. Let's clean this off a little bit and then do the test. Eekpie is asking, what's the fault? None or some? Yeah, that's a good question right now. So this one, the original problem seemed to be a disconnected wire, specifically the green one, which is the incoming data. But now it's looking more intermittent, like it might have just been like a bad solder joint. So, oh, Cloud is joining us. Hey Cloud, you been staying out of trouble? Kinda. Be gentle here. Oh, Servo AF is doing pretty bad here. Oh, that's a good call. And Nexus says, when I hot air those chips, I usually cover nearby chips with copper foil to keep the air from harming them. And the ones I'm working on, I place an aluminum tab on top, roughly the same size. That's a good idea. Why the different metals, copper versus aluminum? I've done the thing where I just cover parts of the board that I don't want to torch with aluminum foil or aluminum tape, just because I had wider aluminum tape than copper tape at the time. But yeah, I'm curious if there's a difference. Like, does one absorb the heat gun incoming convection a little bit faster or something? You know, I'm looking at this solder joint, and the minus the ground is actually sticking up quite a bit. I think it might be worth fixing that. And there's still flux on that joint, right? I think I was actually trying to put that through the via, or was I just standing it up on the via? What was going on there? Either way, not the most helpful. I kind of just want to lay this down. I should trim this. This is not good. No, get off there. Ugh. Gross. Let's get a better edge on this wire. Oops. Tweezers. That was unnecessary, but I enjoyed it. How did it put it back on? This one needs all the help it can get. Let's give it a little flux. Fresh flux. Morgan says that strip action was quite possibly the best use of a microscope I can think of. Yeah, I should have had the direct recorder running. Well, I can get that shot again if I need to. Yeah, usually when I record microscope stuff for the edited videos, there's a separate recording that I do to keep it free of all the overlays and stuff and record it with more bits. But I didn't have that running right now. Maybe I should. This is not too boring. Maybe I can use it as B-roll. There's so much need for B-roll, right? Just like videos of stuff that you can insert to keep the flow paced just right. Okay, I think that'll be all right. Morgan says, oh, scanlime, have you considered a teensy and some key switches and caps to make an OBS scene switcher? Yeah, I already kind of had a project like that a while ago. I tried to be fancy about it and ended up using it to prototype some interesting techniques that I wanted to try at the time. And as a result, it turned out to be an interesting prototype for those techniques, but didn't actually really work out that well as a scene switcher. So the thing I'm using right now is a commercial thing that just has a row of buttons that you can macro. But the thing that Adafruit made was, yeah, it was basically a teensy and a bunch of buttons. And I used a teensy also, but part of the reason it was a little bit tricky was I was doing it on FlatFlex, and I needed to keep the wiring very narrow to keep the FlatFlex as flexible as I wanted. And the way I decided to do that was to have all the buttons act like taps on a big variable resistor. So you'd push a button, you'd get an analog voltage corresponding to what button that was. And that was all right, but there were some problems with it not settling very cleanly, and the voltages were not super predictable, and I probably just needed to fuss with like which analog reference I was using, and maybe pick slightly higher accuracy, lower tolerance resistors. But it was just kind of hard to debug at that point, and there were other problems with the form factor. So I had made it to test this flexible design that I wanted to kind of fit around curved surfaces here, but it just wasn't quite flexible enough to be useful in the way that I intended it to be originally. And so it was a nice prototype, but I learned some things, and I didn't actually end up using it as a long-term fixture in the lab. Oh yeah, these two outputs I don't actually need. I'm just going to try this other technique for capping off the ends. So I tried just putting a heat shrink cap on, but those can just slip off. So I was going to try cutting the wire under the insulation a little bit, which I don't remember if I can do on this type of wire, but let's see if it works. You can kind of push insulation back just a little. I don't know if I trust that for insulation though. Yeah, might be better off just using, maybe wrapping a layer of Kapton tape and then heat shrink to keep the, because I think the Kapton tape, that'll be sticky against silicone. I just want to keep these wires handy in case I add additional LEDs, but I don't want them to short out against anything. They'll just be kind of flapping around otherwise. Heat shrink. Yeah, shut up. Oh, thanks for the link. Yeah, that was the flexible keypad I made. And yeah, that used a teensy, and you can just see the Arduino sketch in there that I wrote to press keys based on the analog voltage levels. And it tries to wait for the voltages to settle, and it has a lookup table based on actually sampling the resistances, but it still wasn't really stable over time. I don't think it was I don't think it's that that approach can't work. I think it's just that mine was flawed. Oh, geez. Yeah, that sounds bad. InnoNexus's comment about drilling the vias. Yeah. So another thing you can do is bundle them together at different lengths like this, so there's no chance they can short out. And this also seems to be kind of where they naturally want to sit. Heat shrink is just going to want to slip right off of this too, isn't it? But now that I've put tape on it, I don't have to cover it in heat shrink, so maybe I can just leave it like this. The tape seems to bond, not well enough. Okay. What about this tape? Something slightly different. Does this have... I don't know. That still comes loose pretty easily, doesn't it? Well, maybe I just use individual pieces of heat shrink and have them be longer so there's more grippiness. So like, this is pretty snug. Put it about 3/4 of the way on. And then the other side, I think we just want to do another jobby where we temporarily attach it to where? I guess I can alligator clip on the power and twist on the data, same as before. These twisted wires keep coming apart. I'm just going to temporarily solder them. I think we should switch to the bigger soldering iron tip. All right. All right, alligators, do your thing. So we got red. Power's off. Longer alligators, maybe. Geez, a 0.3mm drill. That does sound annoying. Do you break a lot of those? I have 0.1mm drills here. They're really annoying. Need a better organizer for all these. Just clipping these onto the same old 5-volt supply. But one of the next steps is going to be actually getting all the 5-volt DC-DC converters wired up the way they're supposed to, and then running this whole project on 12 volts. Because then we don't have to just run piles of alligator clips to get all the lights going. We can actually just throw one switch, and that would be great. Alright, so there's the power. Data out is over here. I have bare stripped wires and slightly mangled solder joints, so I'm just going to temporarily bodge these together with a soldering iron. Alright, super bodgy soldering joint, but it'll work to test this. Just need to remove anything conductive. Okay. This is a little bit sprawling. And this is still connected. Yep. And is the program still running? Oh, so much conductive debris. Program. Now let's run the Python program again. Okay, that should be ready to go. Let's throw the power. I don't see anything. Oh, maybe it was just too dim with the studio lights. Let's set this demo back to the bright red or white blobs or whatever we were doing. Okay, now it's sending the much brighter blobs. I'm going to turn on the power. Okay, those are working, but not the new strip. I'm going to boot up the oscilloscope, maybe. Let me just check voltages first. Well, we've got 5 volts here. Shocking, I know. I'm also noticing this green wire only has 1 green band and not 2. Oh, that's because the other one slid down. Okay. It's fine. So we could still have a broken LED on our hands, but let's just get the O-scope over here to try isolating that. Oh, Cloud's over here on the couch, interested in what we're doing. I still have a 1 amp current limit, and it's not hitting that. Alright, so first let's look at the inputs. There's data. You can see the impulse is moving down much more clearly now. So the way that these work, you get a frame that starts with 0s, ends with 1s, and in the middle there's pixel data. And each LED takes some of the pixels off the front, replaces those with 0s, and then sends them along. And then in clock. These look fine. That is the actual solder joint on the leg of the chip. So we are seeing the data making it to the to the APA 102 chip. There's the clock also on the chip leg. Ground. Or something. I think that's the 5 volts. Yeah, this is looking like the first LED is busted. So let's cut it off and do a splice and hope it's only one. Morgan says, what does the APA 102 signal look like halfway through the strand? Well, I can show you, but I doubt we're going to see anything if it's not coming out of the first LED, because there's just nothing there for the next LED to see. I checked the output pins on that first LED, if you didn't see it, and they were steady state. One of them seemed to be, like, at a weird voltage, so... So here's, oops, that ground was bad. Let's have a better ground. This one might be slightly better. Okay. So there is data and clock at the very beginning of the strip. This time I'm probing the big pads that you're soldering to. Is that plus? Yeah. So then here's the next. We've got ground, data, clock. Oh, the clock's getting through. Okay. So I guess the clock amplifier part of this isn't totally busted. But the data is not coming through. So it's probably just a bad bond wire. It's like we can't see it in the microscope, but it's probably just very subtly cracked in there. Okay. So that means we're just chopping off the first LED, then kind of recreating this work with a fresh LED and bonding that to the strip we already have. Which means scissors. Good old-fashioned scissors. Yeah, I need to take the solder joints off first, though. Otherwise, I'm just going to be cutting through a bunch of silicone wire that I've already prepared just right, and I'd rather save it. Where are the tweezers? I guess I can use these. I kind of want the yellow tweezers, though. Under the meter. Oh, Emily says finally found a good use for the RII I-28 cat can't stop me using it when she's on the desk. I don't remember what that is. Is that an input device? RII. Oh, or is that a tweezer? So you can see I soldered this a little weirdly. I stuck the power on the next LED down and then the data on the actual end. All of the rings are wired that way. It's to keep the wires, to spread out the solder joint so they aren't quite as all bunched up, which helps them fit in the tiny groove that's available. So I'll want to keep doing that, I think. Andrew Nexus says, I think it's time you built a gesture pad for Tuco and learned to communicate with your cat more efficiently. Yeah, maybe. Why are you being so snarky over there on Twitch, D. Bryson? They're saying, so why broadcast on Twitch if you don't plan to respond? Well, maybe it just takes me a sec to notice every single message sometimes. And there are a lot of reasons to broadcast on Twitch. They have some nice features, like I like their clipping. I like that the video archives are available immediately. But, you know, it's nice to not be locked in also. So I broadcast elsewhere. And YouTube has been nice because a lot of people are already on YouTube and know about my videos there, and so it's kind of a more continuous community coming from there, whereas Twitch is a little bit more separate right now. Alright, we've got 2 of these precious little diodes. These I don't need to be quite as careful with the alignment because they just kind of fit into a ring. They don't have single holes that the LEDs all have to fit into. Yeah. I don't know what to say about people whose only contribution is that they're mad at being ignored. It's like, well, I'm sorry, but I don't know what else to say. Maybe if there was something else there, we'd have something else to talk about. I think it falls into the same general communication failure category as people who, like, sometimes there are big IRC channels where, you know, people ask and answer questions, and then people get stuck in the state where they're asking whether it's okay to ask a question, and then nobody responds because no one's like in charge of saying like, yes, it's okay, because that's just the whole point of the channel is that people ask questions. And you can end up in that same kind of deadlock. Yeah, if you're in Gitter chat, you can do markdown formatting for better or for worse. These are really sticky and covered in flux, and I need to tape them together before soldering so that they don't... Like, I just said that the alignment isn't that critical, but I want the alignment not to be terrible. I think I'm just going to stick them both to a big piece of Kapton. Okay, well, D. Bryson66 says, okay, well, that was a pretty good response. I'm glad you're satisfied. I mean, you know, you gotta have boundaries here. I'm not in charge of your satisfaction for sure, but like, if it happens that you liked it, then great. Glad that worked out. Oh, I hear the cats hissing at each other again. Oh, everything here is so sticky. Maybe I just need to tape this whole strip down. Yeah, and then I can tape the other thing to the other strip and then just flip the whole assembly over. And this is just going to be like pick and place time, right? Yeah, I like that Gitter has an IRC bridge. I haven't really used it much myself. Some people seem to have an okay time with it. Other people seem to hit bugs in it a lot. It is open source, so we keep saying, like, there's opportunities to fix it. But, you know, that requires committing work to a project that isn't yours, which is also unpopular. I think these are close enough. I managed to move it just a little bit as I put the tape on. Maybe I keep these attached to one and position it. Oh no, because that's kind of dragging. Oh, is YouTube having trouble for people? I'm sorry. From over here, it looks fine, but yeah, I don't know. I don't know if that's a problem with YouTube on the transcode end, or if there's some network congestion over here. Yeah, let me know if you have trouble on YouTube. You could always try going over to Twitch and see if it's any better over there, and let me know. I'll just hit the camera with my head. It's the best way to do electronics. Yeah, that's fine. Let's get a fresh piece of Kapton. Okay. The goal there was to kind of let the tape contact at least those two LEDs before I kind of put any sideways pressure on it. It's still not quite lined up. It's probably close enough. Maybe it's easier to look at that monitor than to try to see it in person while the camera is there. That should be fine. Haha, camera on head electronics. Yeah, maybe. I don't know if we need the camera to be moving around that much though. That sounds kind of motion sickness. I mean, I kind of like the Snapchat spectacle footage that Noe and Pedro post on, you know, like on Twitch when they do projects, but that's often in short bursts. Like I feel like if you were watching that continuously, it might be a little hard to stomach. But I don't know, maybe it would be fine. Oh, I think somebody's playing with the bolts. I don't know why I'm not doing this under the microscope. I want to do the thing where I give myself more, I don't know. I want more surface area to solder, so I kind of want to scrape the solder mask a little, but I also don't really want to mechanically fuss it that much right now. So I could scrape it after tacking it down. I could also just try to do it like this, without additional scraping. What I could try doing is like just tacking across one of these using a lap joint or a butt joint, which is not going to be very strong, but will hold it in place while I put some wires over the rest, I think. Oh, so Emily says they saw the ones on the disk that were working. Yeah, so those are identical to this. This is just the third of those two units didn't work, and it seemed like a problem with the solder joint on the data line going into the first LED. Looking closer at it, it seemed like the problem was inside the LED package. So now the solution is to just replace that first section of the LED tape. Oh, Draven suggests putting a gimbal on my head. Yeah. I don't know, maybe that would work. That sounds uncomfortable. Okay, so now I have two of these terrible little solder ball joints like they would often do when manufacturing the cheapest LED strip. Those will hold it for now, but I want to put some little pieces of wire on there. thing where you pull out the wire a whole bunch and then have to reel it back in. Right. A video of a chicken sitting on a Steadicam rig. That's funny. Oh man, getting that little wire to stay put is super annoying. I think it would be easier with some flux. Yeah, 4 gig limit. That is not my favorite feature of this camera. Oh. Let me reset that. I think you triggered... Oh, I guess you didn't. I thought that aspect ratio was higher and you triggered the scrolling bug, but I guess not. That's better. Using enough flux and then maintaining control of one tip of this with the tweezers. You don't want to hold it too close to the joint because then that's more heat sinking than you really want. And then you also need both sides of the both pads that you're joining to already be wetted with solder. Maintain control, because otherwise it'll get sucked in. Surface tension will actually just suck it into the joint. Did that work? I can't tell if the right one is wetted. It looks like it isn't. I need a little more solder. Oh, it keeps sliding in and I can't get it out. Come on. Okay, let's get a better grip on that before sending it back in. And let's put more solder and more flux on here before sending it back in. This just does not have the biggest pad. That's part of the problem. Maybe it is worth just abrading this a little bit. It doesn't seem like I should be doing this without a microscope. I guess I can put it under there now that this is no longer as fragile. Oh, yeah, Emily also suggests a very sensible strategy of using a larger piece of wire and then clipping it afterwards. Yeah, that's a good point. That might have been easier. That's better. That's probably enough. Is that a cat-related noise? I think that works. We'll know in a second. Alright, and then... You know, I can actually probably swap these out for the actual wires I'm using for ground and power. But then the input data needs to go up here, so that requires a little more scraping too. I feel like there should be a countdown to when I decide to give up on this temporarily and walk to the convenience store and get an IPA. Would it be a nice stopping point to at least get the LEDs all working? And I think it might also be nice to try mapping them, or to try at least having some really basic patterns that use that mapping in Rust. So something that moves around spatially the way the LEDs are laid out, and then it maybe is easier to see animations kind of in polar coordinates along the ring once we do that. I say polar coordinates, and I don't know if I'd actually program it like that. It would probably be just like a three-dimensional function that you sample along the ring. But yeah, animations like that. I don't feel as guilty about doing a lot of arctangents if I'm running this on a desktop machine. But I could also add an angle to the model if I don't want to be dealing with Cartesian coordinates all the time. I don't know, I don't like angles that much. I like vectors. I like using unit vectors for you know, headings. And with that, like if I have a unit vector that tells me where the camera's pointed, for example, then it would be easy to use that in the animation for the ring. So I hadn't really decided how that light animator structure in Rust should convey per frame details for the ring animations. But I'm thinking it might be something along the lines of, you know, kind of like I had those blips in the test, the little light particles that would move around. I think it would be a little bit like that, where I would have a small number of those, and then each one would have a mask indicating which LED rings, or maybe like where it's centered in space. And that starts to look a little bit like just a particle system, where you have particles that have an XYZ location and some radius of influence, and then you kind of sample the sum of all the nearby particles at every LED's XYZ location. And so I've started down the path of actually doing that in Rust a little bit, but not in the current. It was kind of like a false start. I started doing kind of a Rust port of this C++ LED library thing that I did for Fade Candy a while ago. So Fade Candy is an LED controller. It has a bunch of examples for programming the LEDs in different languages on just a desktop PC or anything else with a USB port. And I ended up programming it in C++ a lot, and the example framework that I made for C++ used some interesting, like it supported some nice stuff. Like you could spread out these LED shaders across multiple cores, and it supported mixing between sort of different LED light environments and setting up chains of animations, stuff like that. And the feature that I think I would most be interested in is that particle system thing where, so you can write a shader that's just a function that goes from XYZ location to color, and then you map all the LEDs through that function. But then there is also a shader function, so it is a shader, you can use it to do that mapping, but then it's implemented based on this collection of particles. So you give it a database of particles. In this case, I regenerate a KD tree on every frame. So you just give it a list of particles, but then it inserts all the particles into a tree, which it uses as an index. And then it can query that tree, give me all the particles within this radius of this location. And then once you have those particles, you can figure out what each of them, you can sum up all of their individual influences on that LED. That's how a lot of the light sculpture type stuff I did with Fade Candy worked. And so I thought about implementing that in Rust. It seemed like a really fun Rust project. I was also getting in over my head a little bit with how new I was at Rust and didn't really know how to do anything that I would have needed. So ended up kind of putting it aside and feeling that I wasn't really ready to implement an entire library right now. I needed to still kind of just play with the concepts while making a specific embodiment of it. So a specific project, not a way of building projects. The microscope would still be kind of useful here, but it's a little out of reach. So I think we're back to the DSLR. Oh, there's a cat on the screen. Oh, and an Nexus was looking at the Fade Candy Git repo. Yeah, it's I enjoyed doing that project. I keep meaning to put some more time into it because a lot of people have been asking for RGBW support. And it's one of those things where if I was making another instance of Fade Candy right now that only had to support RGBW, it would be an almost trivial change. But the change is necessary to support multiple pixel formats, and the change is necessary to have the Fade Candy server do firmware updates. That's where it actually starts to get pretty hairy, and that's why I've been procrastinating it. But yeah, it seems like people would like it. When I designed Fade Candy, I wanted to make it something that wasn't going to necessarily turn into a kitchen sink that can do everything, but was more like pick one thing and do it well. But adding the variants like the RGBW neopixels, that seems like it might be something I should keep within scope, right? Like it's just so close. Like it just needs, it has enough memory. It's mostly the same format. It mostly just involves laying out the memory differently. But then things get weird when you want to still have open pixel control compatibility, because if some program is sending you RGB, do they now need a different command to send you RGBW? Is the open pixel control server trying to kind of synthesize a W value by looking at how much desaturated white there is in the pixel value? What are they doing? Do we have enough flux? I think there's probably enough flux on there still. So I'm just going to try to reuse these wires and put them all into place. And the power supply is off. I don't know if I can do that with tweezers. That fine line between, I don't know if I can do this with tweezers, and I don't know if I can do this without tweezers. There's plenty of flux on this still. Alright, yellow on the left. Green on the right. And best of all, the other ends of all these wires are already connected. I didn't even unhook them. So we just need to throw the power supply and maybe clean off some of this flux. See you later in Twitch chat, D. Bryson. This is kind of a weird sandwich of tape because I had the one tape piece on the front because that's where I could put it during the alignment stage of this operation, and then the other piece was on the back to hold it down to the board that I was soldering it on. There's a decent amount of goo on this board. Alright, I should clean it more thoroughly probably, but I'm just anxious to test this before doing too much of that. It looks pretty well lined up. You can see the edge of the strip is not really that well lined up, but the LED itself seems a little closer. Either way, this is going to be behind enough of a diffuser that I don't think it's going to be that big of a deal. Alright, I think we're throwing the power again. That's a good sign. Let's just run this through all the color primaries, just to be sure, but I think we're doing good. Yeah, that's better. And if we wanted to make this a little bit less repeaty, because right now it's a repeating pattern, and if we wanted to see it perhaps only once across all of these LEDs, I'm just going to make it 10 times longer. Okay, that's maybe too long. How many LEDs are we actually dealing with here? This was 36 times 3 plus 7 times 4 is really, and my console is broken right now. That Windows SSH is not the best. 172. Oh, no, that was with 4 rings. 136. going to try having it send out exactly the right size packet for once. Yeah. Oops, why does that need my password? There we go. Didn't have a key on this machine for some reason. Probably because it's this weird Windows SSH server. Kind of, but more narrow. Let's increase that exponent even further. That's a little more illustrative. Oh, I think it's twice as long as it should be. That's better. And then other color primaries. Yeah, just a little easier to see that the brightness is uniform. That's nice. Okay. I'm done with all these like individual tests. Maybe let's revert this to the one that actually looks good. Why didn't that work? I just did a git checkout and tried to run it again. Oh, wrong IP address. Right. Okay, there's some stuff happening. Now it's hitting the current limit. Alright, I bumped up the current limit to 2 amps, and now it's drawing about an amp and peaking at around 1.3 amps. That's fine. I mean, I'm planning on using separate 1.5 amp regulators for a couple of these, well, DC converters. Johnny asks, is that strip between the wheels and the lid the repaired stripe from the original third wheel? That's exactly what it is. And yeah, it looks like it's working. I had to replace that first LED. We had some bad experience last time trying to use the hot air to replace an LED, and so this time I just spliced in another section of the strip. Pink, white, blue. Oh yeah, I didn't have much of a color picker going on here. There's a little hint of that, isn't it? I had mostly just typed in some values. This is what the code is right now. Yeah, we do need the close encounters of the third kind mode, and this is probably a good start. But alright, now comes the annoying part of actually getting this ring back together. So we'll want to leave this ready to test easily, but I'll turn off the power supply so it's not quite as distracting. I mean, with the studio lights back on, this is probably a little bit less rave mode looking. It's amazing what some ambient light can do, right? So, I think this was going to be the top, this was going to be the bottom, and that's the seam. Don't crush it this time, please. I'll try not to crush it in that way. I'll try to only crush it in the crushing it sort of way. So I think I just want to keep this piece in. It kind of presses the LEDs a little bit. And then these wires are slightly annoyingly short. I think I'm at least going to unhook these power wires temporarily. Data wires, probably long enough. Why didn't I run the output wires the opposite direction? That's right, this is just really tight. I should have added more room for the wires in these. That's right, can I zoom into what's going on here? This is actually slightly complicated and annoying, like most of these projects. So, I've got this groove that the LED strip sits in, which is a little hard to see because it's black plastic without a lot of contrast, but okay. So you can see there's a little indentation, maybe if I can run a tool through it. So this is the surface right here that the diffuser sits on, and then go down into this groove, and this groove is actually what the LED strip sits in. And then there's a wall behind the groove that doesn't go all the way to the middle, but most of the way, and that's just kind of a backing to press the LED strip on the other side. So the wires have to come out through here, and then go through this little gap and then around, or likewise through this little gap and then around. But that doesn't really, like the other problem that I ran into is with these strips butting right up against each other, there's no room for both the wires to come out toward the seam. At least one of these has to come out away from the seam. So, and then they have to reverse. So I'm realizing this would be much more straightforward probably if this side came out toward the seam and then this one didn't and then this one looped around. So it's like the exact opposite of what I've got here. Do I feel like doing that? I don't know. I mean, the other option is just what I was doing before, where I just looped around all the wires with it in there. Let's just try that. I might have to resolder it, but let's see how far this gets me. So, oh yeah, the other thing is I can slide this relative. Oh, right. Never mind. That was the trick. The seam doesn't happen right at the wire entry. The seam can happen to one side of the wire entry. And then, right, I'm gonna have to calibrate the angles of all these rings a little bit, maybe. Like, I'll probably have some test pattern that does a rotating thing that should be lined up between all the rings, and then try to get that close with the model. So I think these all want to go that. I'm also noticing that this part that's sticking up right now, so the piece of the LED strip that I just joined, it's actually slightly wider, so it's actually sticking up slightly. And I don't think it's really crooked, but just the LED strip itself is not uniformly sized. So I think I'm just going to trim that. Okay, that's trimmed flush. So now what's going on is the wires there and there, so the data in and data out are going over and then out. The power is mostly going straight out. I think that's how this is actually supposed to fit. I think that's it. And then the output data can snake through these. I think that's right. Let's see if the other side fits on. And then the whole method of putting this together is kind of annoying. Oh, I'm also realizing this, damn it. This was supposed to already be on there. I could cut the data wires and then resolder them. I'd rather just put this through though. It's fine. That way. Okay, take two. Kind of like that. And then this has to go on just right. I don't know why I didn't just design this to be the same on both sides. I thought this like 180-degree symmetry was a good idea when I designed it. Okay, that is close, but not aligned. Let's try this spudger thing. Hey, Cloud. Cloud is just sniffing around right by my feet here. It's really hard to tell where it's catching. Like, it would have been nice to add some chamfers in key places to help direct the LED strip into the groove. Oh, I think I see it. I should at least clamp the side that's, where's my clamps? Start clamping the sides that are actually in. No, this is in. It just feels like it's the edge of the seam, which is where you'd expect it to be. Just don't see exactly what push it wants. This is really close. Little shim. Yeah, this is where it gets crushed, if it gets crushed, right? Oh, that might have been a good noise. It's pressing back a little bit, but I think that might be the silicone wire. I think we're good. Let's test it again, fully clamp it, and then glue it. Well, put it on the alignment jig, and then fully clamp it and glue it. Oh, I've got to get the alignment jig out of the robot. Yeah, I'm not going to worry about clamping that just yet. Let's just test it. Power, wire it back up. Hey Cloud, what you nibbling on? You still got already limbs? Cloud still seems to have his limbs. Alright, that's looking good. You can definitely tell that's the seam end. The other sides look continuous. Oh, yeah, no, I 3D printed these diffusers. I've done laser cut diffuser projects before, but this was a 3D printing project. And in this case, I wanted it to be rotationally symmetric. So, like, I can imagine with a laser cutter, I could have made something that maybe would have had an interesting pattern along the circumference, but I don't know. Like, I mean, I could have just had, like, a disc of, like, lighting acrylic, and that would have been another way to do it. I just wanted to try this. This is clear NinjaFlex, actually. NinjaFlex, I mean, usually you use it because it's flexible, but it's actually also a really nice LED diffuser material. There's a little one. Do better with a C clamp. Also, like I said, I need the alignment jig, which is annoying. Maybe I just take it off from the bottom. Let's try that. This is one of those things where this is how you ensure that the two halves are totally lined up relative to each other as you glue them is you put them on the spindle and then clamp them into place and then take them off. That ensures that you can get them back on this after you glue them. So this was taped. Oh, another YouTube hiccup, I'm sorry. That's weird. YouTube seems to be receiving the data continuously. I wonder if it'll all show up as one archive. Alright, so this is the piece I want off. I think these screws are already loose. Yeah, so these are just held on by the carbon rods. And the coax. I need to take off the coax. Alright, so the coax stays. This will say come off for now. And then I carefully get these two carbon rods out of the base by spinning them a little bit and pulling them up. There we go. And now that part is kind of free. Kind of hitting my lamp. Okay. Just in case you're worried about how we would ever get that apart, there is a way to get most of this apart. It's just slightly annoying usually. And that's how it works underneath. There's this clamping bracket which is bolted down to the actual bottom of the robot. Okay. This is 180 degree symmetric again. It can go on either of these two ways. Alright, this is where these wires have to go to one side or the other to avoid this post. I think this part, some temporary Kapton tape usually helps with. That didn't quite have the effect I needed. That's more useful. I want to stay out of the way of this middle area because that's part of where the glue needs to go, but it's also not super accessible during this first alignment stage anyway. Gotta make sure these are properly spudged. I think that was it lining itself up slightly violently. Oh, I should give Luna her medicine. Oh yeah, that is a little tight. Maybe let's take off these clamps for a moment. Feels like there's just a little bit of tightness coming from the silicone wire still. And I have some wires crossed under here that don't need to be crossed. This is just all going to come apart. Oh my gosh, how did I cut that wire? I mean, I didn't cut all the way through it, but I broke the insulation with the spudger. It's got nothing next to it to short against. And it's a data wire. But that was annoying. I'm about to put glue in that area anyway. Oh, Cloud is on the desk now. Dude, you don't want to be that close to the soldering iron, do you? This is the cat that is supposed to be taking it easy, getting over a broken leg, while recovering from the surgery he had to fix his broken leg. That's better. That feels like it's supposed to. That's better. Okay. I think that it's finally ready to glue. Let's give it one more test. And maybe before we have our gluing finale, I can give... Oh, don't chew that, Cloud. Cloud, why are you even over there? He's leaving on his own now. Well, that was the cat painkiller situation. She just needs a tiny bit of medication, but she doesn't like it. The Pareto method? Oh, is that wrapping her up in a little blanket? Alright, it's pretty late here. We should wrap this up. But maybe there's time to at least glue this together first so that it can be ready to install next time. Alright. Hot glue gun. Black hot glue stick. I should have started this warming up before feeding, or before giving Luna her meds. Yeah, I think this is fine. So the way this was held together was mostly along this edge, just like really getting glue all along this edge, and so there's some old glue here I'll have to go in there and melt too. I think that, oh, beer, man. Do I still have time to go get beer? This convenience store is open 24 hours, but I don't know how late they sell beer. Okay. I really don't want to wait for this to warm up. I think maybe it's time to call this a stream and come back to this later. This seems like a natural stopping point. We can glue this together, test it all, do some more Rust code. It'll all be fun, but it's like 10 o'clock here, and I should go get beer. Well, thanks so much for tuning in, folks. And yeah, special thanks to everyone who sends a few bucks my way via Patreon. It keeps the lights on in the shop, and it's super awesome. And I will tell them the internet sent me. I'm sure he'll appreciate that, the cashier. Alright, I will see you all next time. Thanks for tuning in. I like the advice, get one that I know I like and one with a cool label.